Hey everyone, welcome back. In this video, I will walk you through my Python notebook where I analyze user behavior data. Here, I will cover what I have done in each cell and why it is important and why I have made this choice. In the first cell, I have imported the libraries like scikit-learn and TensorFlow. Scikit-learn is essential for pre-processing of the dataset, things like encoding categorical data and scaling numerical features. TensorFlow, on the other hand, is a go-to library for model building and the training of the neural network. In this cell, I have loaded the dataset which has the data like device model and the age gender of the user. Here we have got 700 rows of data and 11 columns. In this cell, I have visualized a bar plot showing count of each user behavior class. This is crucial because it reveals how well they distributed of our target variable is and the balance of the data. Here, I have used label encoding to encode the categorical data into numerical data. In this step, I have applied one-not encoding to the operating systems and the device model columns. This converts the categorical values into binary columns, enabling the model to process them as a numerical data. This is the final output of the preprocessed data. Here, I have visualized the heat map of the future, which shows the relationship between the numerical features in the data. Here, the dark values represent the high correlation and the light values represent the low correlations in the dataset. In this, I have splitted the data into independent and dependent variables. I have dropped the user ID because it is not necessary for the model training. And I have dropped the user behavior class because it is the target variable for our data model. Here, I have used the standard scalar to scale the numerical features. It standardizes the feature by transforming them to have a mean of 0 and standard deviation of 1. And the Y encoded is the function from Tensor Keras utils that converts the label into one not encoded format. Here, I have splitted the data into trained data and the test data, retaining the 80% of data for training and 20% data for testing. Here, I have created the sequential model using TensorFlow neurons ranging from 128 to 5. I choose ReLU because it is computationally efficient and helps the model learn to complex patterns without vanishing gradients. In the first layer, I have used 128 neurons, and in the second layer, I have used 64 neurons, and at the last layer, I have used 5 neurons and activation functions as softmax. I use softmax because it performs better in multi-class classification problems by converting the raw scores into probabilities. Here, I have used Adam Optimizer with learning rate of 0.05. In the model compilation, I have used categorical cost entropy for the loss function and the accuracy as metrics to denote the model performance in the terms of the correct prediction. Here, I used yearly stopping to monitor the validation loss. When the validation loss stops, it stops improving for a set number of approaches. Training halts automatically. I have fitted the model using X-train and Y-train, which represent the dataset with a batch size of 32. The model is trained with 20 epochs, and I have included validation using X-text and Y-test. Additionally, I have implemented callbacks for early stopping to prevent the overfitting and stop training if the model performance stops improving. This is the overall result of the model training, and we have got almost 98% of accuracy in this data. In this step, I have visualized the training and validation accuracy using line chart. The blue line represents the training accuracy and the orange line represents the validation accuracy. This helps us to compare how well the model is performing on the training dataset versus the validation data over the approaches. It is a great way to monitor the potential overfitting where the training accuracy might keep increasing while the validation accuracy decreases. It is especially helpful in model performing is getting worse and we can spot the overfitting early. In this step, I have visualized the training and the validation loss using line chart. This is useful for monitoring how well the model is minimizing the error over the time. If you notice the training loss decreases while the validation loss starts to increase, it could be sign of overfitting, where the model performs well on the training data but struggles to generalize to new and unseen data. So it is helpful improving the model performance. In this line, I have printed the training accuracy. We have got almost 98.75% of the training accuracy and test accuracy as 100%. Here, I have plotted a bar chart that shows the important features based on the average weight magnitude of the neural network first layer. The idea is the future by higher absolute weight are considered more influential in the model decision making process. By sorting the feature in descending order of their weight magnitude, we can identify which feature are contributing the most prediction. Here, here I have used the trained model to make predictions on the X dataset. The model output prediction in the form of probability for each class. I have used npm argument max to convert these probabilities into class labels, since the classes are encoded as one-not vectors. Here, I have selected 10 samples from test sets for comparison. For each of the sample, I extracted the actual class label by using argument max of the Y test to convert the one-not encoded values back into the class labels. Then I retrieved the predicted values from the prediction from the model and made a data frame. Here, we look at the bar chart comparing the actual and predicted class label for sample of the data. The model prediction are compared with the true values which are encoded using one-not encoding. The chart gives us an intermediate visualization of how well the model is performing by showing how close the prediction value is to the actual value for few selected samples. Thank you for watching. I hope this video helped you to understand the process of analyzing the user behavior data and the model building.